Now we ask if we can find still another point on this plane. And that's easy to do. Now I'm going to fudge a little bit and choose a point that I think will come out with whole number solutions. I'm going to let y equal 1 and z equal -2. So let's let y equal 1 and z equals -2. Our equation becomes 3x minus 7 times 1 plus 6 times -2 plus 47 equals 0, which becomes 3x. This is going to be minus 7 minus 12, so that's minus 29, and we end up then with 3x plus 28, it just doesn't come out a whole number, equals 0. We get x equals -28/3, about -9 1/3. So now we know that the point -28/3, 1, -2 is on the plane. Now let's see if we can verify this. Okay, verify. Now recall that the original condition for this plane was that the point 2, 5, -3 lie on the plane, and the plane be normal to the vector 3i minus 7j plus 6k. So if we draw a point and label it 2, 5, -3, and a normal vector that we're going to, and let's make sure we get this right, 3, -7, 6, that's 3i minus 7j plus 6k, and a point representing -28/3, 1, -2. Does the vector from this point to this point make a right angle with this normal vector, as it must if the point is to lie on the plane? Well, this vector is, now it's -28/3 minus 2, 1 minus 5, -2, minus -3 is -2 plus 3. And I'm going to put an arrow over that to indicate that these are the components of a vector. And actually we use kind of pointed braces also to represent a vector. And this vector is going to then be -2 is -6/3, so that's going to be -34/3i minus 4j plus 1k when we add up these numbers. Now the question is this vector perpendicular to this vector? If we take the dot product, 3i minus 7j plus 6k dotted with -34/3 I minus 4j plus k. If this vector is perpendicular to this, then the dot product is going to be 0 and vice versa. If the dot product is 0, then the two vectors are going to be perpendicular. Now 3 times -34/3 is -34. -7 times 4 is plus 28. 6 times 1 is 6. And that does add up to 0, showing that this point does lie on the plane, and verifying our technique for finding a point on the plane. Once more, you can choose any two values. You can choose values of 2 of the 3 variables, solve for the third, and get a point on a plane.